Okay, we're going to talk about experimental design. So what's the definition of an experimental design? Well, we have two different options. We could have an observational study where we simply observe outcomes without imposing any treatment. Okay, we're just observing what's happening from somebody else's choice. Or we could have an experiment where we actively impose some treatment in order to observe the response. Okay, so the big difference between a study and an experiment, you have to tell somebody to do something. You have to impose a treatment. So I've developed a new rabbit food, Hippity Hop. Oh, it says it increases energy, makes fur soft and shiny for my rabbit. It increases their energy, and it has 100% of daily vitamins and essential oils. So can I make this claim about my rabbit food? No, I can't. How do I know it makes the fur soft? How do I know it has all the vitamins? How do I know it's going to improve and make the rabbit healthier? You don't know unless you actually do an experiment. So what should I test this on? Well, obviously you should test it on rabbits. What do I test? Well, you're actually testing, is it the food that is actually making the healthier rabbit and not something else? So an experimental unit definition, make it a flashcard, the single object, an object, it could be a person, an animal, plant, etc., usually a noun, to which the different treatments are assigned, okay? So in our rabbit food example, our experimental unit is the rabbit. We're testing it on the rabbit. Factor, well, what's the factor? The factor is the explanatory variable. An explanatory variable is also the X variable if you think about it mathematically. A level is a specific value for the factor. Sometimes we can have more than one factor, and we can have different levels of the factor, and we'll show you examples of that here in a minute. So explanatory again is your X. Think of it mathematically as your X. What comes first? The variable that may help explain or predict changes in a response variable. Okay, but explanatory has the X. It is the X variable. I need that first. Response variable is what you measure. Okay, response is what comes after the output from your input from your X. So treatment, okay, treatment is a specific experimental condition applied to the units. A specific experimental condition applied to the units. So in our rabbit food example, our treatment would actually be the rabbit food. That is what we are thinking is causing the change. So make these flashcards, study. So if we, again, going back to our rabbit food example, what are the experimental units? Who are you testing it on? I normally say object, noun, that is the rabbits. What is the factor? Well, the factor is the type of food. And what's the response? What are you going to measure after you give the rabbit the food? Well, that is how well they grow. Are they getting healthier? Or is their fur getting shinier, etc.? So I have my Hippity Hop rabbit food. I'm giving my rabbit the food. He ate the food. Since look, his coat is shinier and he has more energy, then Hippity Hop is a better rabbit food. Can I make this claim? No, I only tried it with only one rabbit, okay? So sometimes in experimental design, we need a control group. Control group, it means that a group that is used to compare the factor against. So it could also be called a placebo or the old or current item. How do I know that that food is making the rabbit fur healthier or whatnot unless I'm comparing it to something else? So a funny little joke here. Maybe it's funny, maybe it's not. I feel lousy, doc. You need to laugh more. Laughter is the best medicine. I must be in the placebo group. Okay. A placebo is a dummy treatment that can have no physical effect. Okay, so placebo is often used in pharmaceutical companies. You know, anytime a new prescription is even put out on the market, you know, they have to test, okay, is it actually the pill that is treating the illness. Okay, so in order to test that, they normally have people, maybe, they take a set number of people, half of them actually take the pill with the active ingredient, and the other half just take a pill with no active ingredients, just to see and measure the effects to see which one is actually helping. Okay, so placebo is a dummy treatment or a treatment of no effect, just to see if psychologically do they think that they're getting better, even though there's no active ingredients. So again, now I have my control group. I got my old food and I got my hippity hop food. Okay, I'm going to use my rabbit and I'm going to use my friend's rabbit. My rabbit gets hippity hop. The friend's rabbit gets old food. Look, he's bigger and shinier, so hippity hop is better. Can I make that claim yet? No, I've only tried it with how many rabbits? I've only tried it with one rabbit. Okay, what if I take the first 5 rabbits that I catch, and I'm going to give them that new hippity hop food, and then the remaining 5 are going to get the old food. So I'm catching my 5 rabbits, they get the new hippity hop. The last 5 are going to get the old. Oh, the hippity hop rabbits, they scored higher, so it's the better food. Can I make this claim yet? Still, not yet. What happens? Let's look at my rabbits. Is this equal, or am I already choosing the bigger rabbits to get the newer food? Okay, so now let's randomly assign the rabbits to the rabbit food. Okay, so let's randomly number the rabbits from 1 to 10 and place them all in a hat and pull them out. First 5 numbers pulled from the hat will be rabbits that get the hippity hop food. The remaining rabbits get the old food. Now I evaluated the rabbits and found that the rabbits eating hippity hop are better than the old food. Yes, you have now conducted a good, proper experiment. So yes, we can make that claim. Okay, so there are certain steps that must be involved in order to conduct a full quality experiment in order to make valid claims. You can't just test it on one, you got to test it on several, and you got to make sure that you're randomly assigning in order to collect results. So sometimes in experiments, we need what's called blinding. Blinding is a method used so that units do not know which treatment they are getting, okay? Think about like if you're blind, you can't see. Double blind is neither the unit nor the evaluator know which treatment a subject received. So think about it if we were doing an experiment with like pharmaceutical to tell if a certain drug is helping a condition. If the patient already knows that they're getting a pill with active ingredient, well, then they might psychologically start doing things that are going to help improve their disease, okay? We may not be able to tell if it's strictly the medication that is helping, okay? So that's why blinding is often done in pharmaceutical type of experiments. And sometimes you need to do double blind, hence the doctor evaluating the patient doesn't even know if they actually got the real pill or if they got the placebo pill. Because sometimes the evaluator knows they're getting the pill with the actual medicine in it. Well, they might be evaluating the patient as healthier. It could sway their evaluation. Okay, so sometimes in experiments, you need to have it double blind to where, okay, the doctor evaluating them doesn't know, but somebody else, kind of like a third party, has written down whether they actually have the active pill or not. That is the only way to determine if it's actually the medication that is improving their condition and not some other factor. So principles of experimental design. Okay, you need a control group. Okay, control of the effects of extraneous variables on the response by comparing the treatment group to a control group. It could be the old formula, it could be no treatment and then with treatment, that could be the control, or often as said, the placebo or the old effect. You need replication. I need to replicate this experiment on many subjects to quantify the natural variation in the experiment. Okay, I can't just test my hippity hop food on just my rabbit. I need to test it against multiple rabbits, because what if there's something different about my rabbit that it's only working on one? And it needs to be randomized, okay? The use of chance to assign subjects. Like in our rabbit food example, if I only choose the large rabbits, well, of course those rabbits are going to be larger after eating the food. So you need to make sure to randomly assign so that you're not cherry picking certain subjects. So make a flashcard: control, replication, randomization. Parts of experimental design. So the only way to show a cause and effect is with a well-designed, well-controlled experiment. Okay, you cannot state definitively that something is directly causing something else unless you have done all the steps. So let's look at an example. A farm product manufacturer wants to determine if the yield of crop is different when the soil is treated with 3 different types of fertilizers. 15 similar plots of land are planted with the same type of seed, but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. So what are the experimental units? Okay, again, the experimental unit is the object that is being tested on, which is here in this example, would be the plots of land. What is the factor or factors? The factor would be the type of fertilizer, what's going on the land, that's the type of fertilizer. Well, how many levels do we have? Well, how many different fertilizers do we have? We have 3 different types of fertilizers: fertilizer A, B, and C. And what about the response variable? Response is what you're measuring. Remember, explanatory is your X. Response is what are you measuring? Well, we're going to measure the yield of the crop, or how well the land is doing after the fertilizer. So how much is it producing? So how many treatments will be involved? There will be 3 treatments. Why 3 treatments? Because we have fertilizer A, B, and C. So this same farm example, why is the same type of seed used on all 15 plots? Okay, why can't we use different seeds on different plots? Well, it's part of the control, right? How do I know for sure that it is the seed that is making the, if we use different seeds, we wouldn't know if it's the type of crop that's growing that is the issue or the actual fertilizer. Okay, so you want to make sure that you're growing the same crop on each land so that that's not a factor. What are other potential extraneous variables that could be involved in this scenario? Well, one could be the type of soil. Some soil in certain areas may not be as good as others. Some could be the amount of water. You know, if you're saying, oh, my crop's not growing, well, maybe it hasn't rained a lot, and maybe it's the lack of water that is affecting the crop growth, not necessarily the fertilizer. So there's always other variables involved. Our goal is just to try to minimize the other variables involved. So does this experiment have a placebo? No, this one doesn't have a fake or a dummy anything. A placebo is not needed for this experiment. So notice placebo was not part of the 3 parts of experimental design, okay? In pharmaceuticals, you often need a placebo, but not every scenario. So just control, replication, and randomization. Okay, make a flashcard. Okay, let's look at this example. We're cooking, so any chefs, this will be of importance to you, or bakers, I should say. A consumer group wants to test cake pans to see which works the best, which one bakes evenly. It will test aluminum, glass, and plastic pans in both gas and electric ovens. So what are experimental units? Again, experimental units are what is being tested on. And that is the cake batter or the cake or whatever object you're actually baking. What are the factor or what is the factor? We have two factors here because we have two different, several types of pans and we have type of oven. So this is an example of how we have two different factors. A pan could be a factor, an oven could be a factor. Levels, well, we have 3 levels for the type of pan because we have aluminum, glass, and plastic. And we have 2 levels for oven because we have electric and gas ovens. Okay, so one may cook differently than another, which bakers in the room actually, yes, you know they do not cook the same. So what is the response variable? Response, again, is what you are measuring. Well, if we're talking about cake here, we are going to see, well, how evenly does the cake bake? How well does it bake? Does it bake through? Whatnot. So how does the cake look after? So what are our number of treatments? Well, if we have 3 levels of pans and 2 levels of ovens, that means we need to test each pan and each oven. So 3 times 2 will get you 6 treatments. And that is part 1 of parts of experimental design.